Day School 3, Software Development for Engineers. This session covers database and database management system, data modeling, ER diagram, and normalization. This content include data and information, storing data, database management system, like that. Data and information. Here we can see data and information. There may be several data. One example here, Sandali Karunaratne and the number. The difference between data and information is data has no meaning. There are some data, and if we say registration number of students Sandali Karunaratne is this number, this information has a meaning. Data, there may be several data, but it has no meaning. How can we store data? Usually, if we don't have any computer earlier, we saved all data as a paper, or with the civilization, most people store data with their memory. After that, they with the finding of papers, they wrote data and all informations in papers. So then the file is a combination of papers or letters and all the other data. After invention of computers and later, spreadsheets were available. Not only those are electronic spreadsheets. Before that also, there are tables on the paper. Tables mean there are two rows and columns, and within rows and columns, data included. Then folders, ledgers. Ledgers are how companies' financial data stored. Lists. There may be list of say list of some numbers, names, name of friends, like this list of piles of papers on your desk. Papers, stack of papers. The file-based system in separate department, there are several files, employees files, salary details, inventory handling, say finance division. Finance division, there are several files available, and like that in several departments, several files are there. Disadvantages of the file-based approach is data redundancy. Data redundancy is sometimes a customer name is available in finance division as well as some other supplies division and any other divisions. Same name may be appear in several fields. Suppose in students in the open university, uh, if you don't have any computerized system, uh, we have to save your data in the registration also separately, and the finance division separately, and academics divisions separately. Your names should be stored separately. So sometimes same name may be in different ways. They can write in different ways. Sometimes spelling mistakes. In one place, your name uh, as can may be displayed as it is correctly, but in other places, sometimes there may be differences. So, mm, in same name may be in different places in different as a different spelling. So sometimes it combination with other names also. These are the integrity problems. Integrity problems is in one place, same name, difference than the other place. That is the integrity. Data isolation is in finance division, their data is isolated with the registration block. So these are the advantages of file-based approach. So if your address is changed, you have to say to all divisions to change the address. If the centralized database is not available. Security problem was also available because anyone can access to that file, your personal data also. Not only that, concurrent access, because you can sometimes your data can be accessed. If we don't have any centralized database, electronic database, there you have if a person need some data, they have to go to the several places. If the um, electronic database is available, just only one place, one name is available. So it's shared to the other place. So only if the student want to if the student or person want to change the name, the student or person should be request to only to one place, IT division. So they will change, and that's only. It will appear, the changes will be appear in all other places if you have a centralized database. A database stored in a computer system, shared collection of related data used to support the activities of a particular organization. Usually, I will explain about what is relational database. In a relational database, all the data belongs to one particular organization is stored. So that storing method and data are different than to the other organization, but in a single organization, all the data are available in a single database. That is single database, centralized database, not actually single database. Shared collection mean relate these data can be shared to all the divisions. Finance division. I can easily give example from the Open University. The registration block, same data is can be accessed in different ways from the different department. Uh, Registration block can access registration number, name, and the courses. And the exam for the academics, they can access registration number, name, and the marks also. Course, program, marks also. But the finance division cannot access marks. Finance division can access their payments, like that. All the data available in a centralized database, but different department can access, and their same data in different ways. In Open University, this data can be accessed uh, by the RES division also, RES in the centers also, they can access in the central database. Here, this example, student shared related particular organizer. Uh, there are 4 tables here. Student, marks, course, program. But these tables are separated. But physically, um, all the data available in the collection of these all the data. But then using database management system, these data can be separately stored. We can create these things. These data can be shared as a different view. Here you can see this here key in this picture. You can see key here, and these field names. These are called tables. There are 4 tables. Table name is student, marks, course, program. Here the complete database is called as student info. You can see student info is available in all these 4 tables. This is the database name. Organization database name is student info. Data here, data stored in this table relevant to the student. Registration number, name, date of birth, gender, address, all these things relevant to the student. These are relevant to the course code, course title, course credit, course level, like that. This is program, Bachelor of Software Engineering, Bachelor of Science, like that. A program code, program name. Here you can see with these numbers available. This is called data type. Integer, vacha, date, cha, vacha, int, vacha, like that. Data type is usually data, types of data can be uh, uh, differentiate for each data. Here, this int mean integer. We can store only numbers here. So int mean not decimal number. You cannot put decimal number 0.25 like that. You can't put. if we if the data type is int, here the length is the 4. Actually, what is the length of the our your registration number? I think 9. I think I forgot the exact value. 9. So in the length of the um, integer we can create as 9. We can give name of the field. This is a field. Student name is a usually we can the data type of this student name is characters. These characters cannot be added, calculate. The length of this is 45. Date of birth is date. Gender, cha. That is the difference between cha and vacha is cha is only one character. Uh, Only one character. Vacha is strings. These are called strings. That is a collection of characters. Vacha 60. Here address we can actually these values we can give. We can think what is the maximum value and we can give the length. Maximum length is 255. But the problem is if we give the 255 for each of all the variables, the memory and the hard disk memory allocate uh, for 255 characters for all each field. That is these are called actually attributes. This field, one field, um, it allocate if we put a vacha 255 characters, it allocate. So the space may be bigger than actual uh, maximum length. Telephone number we can put anything. Here we have put 10 integer. We see also vacha. Here hash sign mean integers. Hash sign mean integers. This sign mean vacha. Here these are called primary keys. How can we access these tables, each table, by using this primary key? Okay. Here there are 3 primary keys related to this because related to these things, and you can access by all these 3 combination of 3 using combination of 3 values. We can access this mark: student registration number, course code, registration year. Because uh, one student can register for 4 years. Um, course code also, if the student repeat, the will be changed. The the earlier year maybe the different marks. The next year maybe different marks. Database management systems. Core is high-level programming language, DPMS, then the operating system, then database. Today, DPMS are essential for enterprise information systems. Actually, now deep database management systems are used in big companies. Not only the big companies, any company can use. Example of this DPMS is Oracle. Uh, DBMS has schema. Schema is views. Okay, now external schema, conceptual schema, physical schema. Describe the files and indexes are used. I will say what is this indexes and files. Define logical structure. Many views describe how users see the data. DBMS is described at 3 levels of abstraction. Here, actually, DBMS has 3 levels: external, conceptual, and physical. Views can be different views, conceptual schema, through the schema. Views can be, views can, um, each view, which view mean application, uh, can be accessed only the conceptual schema. Schemas. Schema is an overall description of a database, and it is usually represented as an entity relationship diagram. Multiple subs, this display multiple external, I will explain later. Okay, here you can see this views, conceptual schema, physical schema, users, application software. In physical schema, these tables are separately stored. Here this PK is primary key. F key is called foreign key. Here also there are 3 primary keys. There are 2 foreign keys. One primary key here, one primary key here. In conceptual schema, these relations are there are relations to these tables. This student table primary key is student registration number. Actually, primary key is unique. Unique means um, uh, there are records. Okay, I will explain later. Uh, for each record, a record is a one single student's data. One single student's how to access this one single student's data by using the registration number. There are here the registration number is unique. So because uh, if the one registration number has 2 students, the electronic database we cannot access it in the electronic database if one registration number is available for 2 students. That is a conflict actually. So that should be unique and not null. The not null means there should not be student name without registration number. If the registration number is not available, we cannot say he or she as a student. So not null, unique and not null. Not null mean not empty. And now here the foreign key. Here you can see foreign key. Foreign key is a primary key of another table. Here this table's primary key is P code. Here you can see P code here. So it is a this this P code is called foreign key. This P code is uh, primary key. Here the this where data type and the length should be same for this primary key and the foreign key. Without if it is different, we cannot in the DPMS we cannot give uh, relationships. Here, this registration number is primary key. Here you can see the key here, and the foreign key here is marks, student registration number. Um, Here the course code is foreign key because course code C code is here the primary key. So this become here foreign key. These are two of primary foreign key. But to access this marks table, the combination of three fields become primary key. Okay, now these are conceptual schema. Now relations are there. But in view means uh, there are two uh, here in the registration block. In the registration block, course code, course title, student registration number, student name, registration year. Combination of here data are combination of table. Here course code is this one. Course title here, course title here. Student registration number here. Student name is here. Registration year is here. Registration year. Registration date, registration year is this one. According to this table, registered year is here. So it's a combination of uh, all tables. Okay. So we mean view in the registration block. These data cannot be edited. Course code and course titles are uh, cannot edit uh, because that is not belongs to the uh, registration duty. This registration number, name, and the registration they can edit. Here, marks. When entering marks, all these can be view but cannot edit. Only the marks can be edited. So that is the views. There are two here in this example, only two views. So in actually, there are so many views you can um, in actual database management system. There are so many views. Users are registration staff academic, so they can access these applications by separate password, username and password. When you give username and password, uh, some relevant registration app will be allocated. And the relational data model is like the same as database is student info. Here registration number and all those things are available. Here data type is integer. length is 4, data type is vacha, like that. Okay, now earlier you can see these tables. Okay, now how can we create this, decide what are the tables you need? You need within the organization. Before creating these databases, if a company which needs the database, usually called a software company. What the software company is analyzing this, the organization. While analyzing and after analyzing, they write a report. And one report is about the data. One report is actually not report. They're saying the same report. One section, what data they use, and what are they doing for these data. That is two different things. What are the data they use, this data for the centralized database, and then application software are designed by using this. What are they doing? What are they doing to this data? I will give an example, small example. Student may register for 0 or more courses. That is when software company analyzing the organization, they write what are the data, what are they doing for these data. Here you can see student may register for 0 or more courses. Now see this in this sentence. See what are the nouns here. Nouns are student and courses. Okay, you can see this in this relationship. This is a relationship diagram. Okay, now uh, these nouns become entities. Here these are entities, square boxes, rectangle boxes, not square boxes, rectangle boxes. Rectangle boxes indicate the nouns here. Student calls. Now action. Here the verb register. What happen? What are doing with this data? Here you can see this action or verb as relationship. Student may register for 0 or more courses. 0 means sometimes they don't need to register for courses. Student may register as a actually studentship. So that is why this 0, 0 means no courses, 0 courses, or more than one or more than one courses. A student, one student. So this verb or action, we write it as this diamond box relationships. Entities are here. Here you can see these are crossfold. Uh, three lines here. Three lines mean many. Many student can register for many courses. Entity. Entity is an object in the relevant real world with an independent existence and can be differentiated from other objects. An entity might be an object with physical existence. Example, lecture, student or car, and object conceptual is a job, course. There are two types of maybe physical entity or conceptual. Course, job, position. Each entity is described by a set of attributes. The entity has set of these attributes. Example is student has name, address, gender, age, like that. Attributes. We can represent these attributes by graphically. Okay. Registration number, address, age, like that. Here you can see registration number is underlined because it is a unique primary key. Here you can write this as ellipse. Draw within the ellipse and other attributes. Name, gender, age. Entity you can write draw within the rectangle box. You can think about what are the attributes for a student, teacher, textbook, etc. Types of attributes. Simple attributes, atomic value domain, name, Dinith, age, like this. Composite attributes, address. Address has sub lines. 59 Park Street, Nugget, like that. Address has a subline lines, some other lines also. That is called composite attributes. Multi-value attributes have a set of educational qualification. Educational qualification is a attribute, but it has sub-attributes like certificate, diploma, BSc, like that. Derived attributes. Derived attributes is age, like age. Age can be obtained by using the if we have birthday and the current date, we can calculate actually age. That is derived attributes. Key actually a primary key, foreign keys, an attribute or a group of attributes whose values can be used to uniquely identify an individual entity and in an entity set. That is primary key. In marks table, here in marks table there are three primary keys, a combination of primary. This is here single primary key. Types of keys. Candidate key. Now candidate key is uh, now say person the we give for a student we give registration number, and also there is a name. Everyone has a name, but name is also a candidate key for primary key. That can also we can take as a primary key, but sometimes there may be clashes between there may be problems between this. Sometimes initials, when we consider the initials, same initials may be in two different persons. So there may be some conflict situations if we use the name. So So we give another primary key as a registration number. That is the most suitable. There are two here. There are two candidates: is name and the registration number. But we select one candidate um, for um, for primary key. Composite key, that is unique or minimal. That the key, that the name also key. A person can identify it by the name. Unique can other thing is composite key. Composite is a combination of two or more attributes. Here you can see composite key. Here student registration number, course code, registration year, both all three variables become three. Actually, these are called variables also. Variables, three attributes. Okay, three attributes become one key. Primary key, foreign key. Primary key is a unique identification attribute for for a table. Foreign key is a primary key is a if a table has a key which which is a primary key of another table. Here you can see relational data model, one table's example. Here one table table name is student. Attributes are attributes are registration number, name, date of birth, gender, address, telephone number, program code, like that. This is field name, student registration number, student name, student date of birth, like that. Actually, this we can write like this ST registration number, like that. A short name. Uh, most most programmers use this data because earlier only limited only limited uh, characters can be given for field names in each database, in electronic databases. So and other thing is they can't write it as write spaces. So here st underscore DOB, st underscore name. Field type is vacha, cha, date, vacha, integer. The field length is here 10, 2, like that. Here the foreign key is here like this. Here this is a record or tuple. We call a row, or we can call this as a row, or record. We can say record also. We can say tuple also. Here we can this includes uh, one student's data of one student. Column attribute columns we say as attributes. Attribute registration number, field name, ST registration number, primary key. Primary key is not null, unique. Not null mean cannot put empty here. And this unique mean we cannot include 1111 here also. It will give actually it will When we give uh, relations, it will give error. We have to give relations and primary key also. Relationships holds the entities together. There are uh, four types of relationships: one to many to many, many to many, M to N to N, the two sides. So we can say one to many and many to many. Uh, when we consider relational database, actually only one to many and one to one is available, not many to many. Business rules to ERD. Most organizations are guided by several rules obtained from their policies, regulations, best practices, etc., specific to business. Actually, I in early example, I have given a student may be registered for zero or more courses. That is a policy. That is a university policy and regulations, best practices, etc. That statement is a uh, actually university can change that sentence. According to that sentence, we can implement the company implement the database. Business rules related to the relevant data in the business are essential for designing computerized database. For example, suppose a university offers several courses for a program of study. We can derive following business rule statement from the above example. A student may register in one academic year or zero in one academic year or zero or more courses. That is, we can extend in one academic year. A course may obtained by one or more student. A course may obtained by one or more student. A student obtained mark for registered course by all these business rules. All the business rules in the company gives to the software company, so they create using these business rules to create database. They're not the database management systems. Relationships. Consider the following business rule. A student may register for zero or more courses. Here we can call as occurrence diagram. We can write some examples here. We can check what is this, what is the relationship. Okay. Now student, there are several student names. We can write just anything. We can write course codes, several course. We can write, we can draw uh, one student can register for many courses. So Nimal can register this, normally can register this course and all these courses. Uh, Here, this course, this ECX3151 has obtained by three students, no? Nimal, normally, and Sandhani. This in both sides, these triangles available. Here you can see this triangle. Here you can see this triangle also, and so because both side has many to many many sides and one side, So so therefore this is called many to many. So this single student can get many courses. This course can be obtained by many students. So this become many to many. But in relational databases, we cannot implement this many to many relationship in a relational database. So we have to create using this uh, using this many to many to become one to many. Here relationship, here many to many, here this is the one. Here 0 mean this mean O mark means 0 or more. If we write this uh, mm, vertical line, it become 1, no zeros. Uh, Here you can see registration number is primary key. Here course code is primary key. Registration here. Change many to many relationship to many to one relationship to one to many relationship. Now this the every actually many to many can be divided we can include uh, we can change it to the one to many relationship by including another table. Here you can see student course. This relationship between student and course is many to many. Okay. Now many to many, we can put here marks. Now student S, student S1 can get M1 mark for this course. S2 got the M2 mark for this course. S2 got the this mark for this course. So all the data become this corner line only one this side. No, there's no corner line here. Here you can see corner line. So this become table and this become relationship. Many side, and this is one side, many side, and the m inside that means both m and n are many side, and here is one side. The mark attribute should be added to the register relationship. This mark appears in the mark sheet. This mark sheet, okay? This mark appears in the mark sheet. This mark sheet becomes an associative entity for the register relationship. Now, here the mark we can we put the another table mark. So this relationship become one to many and one to many here, and then. We can put this as a another table mark sheet, and the many side is here. One side is this one, this side is many side. This is 0 or many. Registration number, course code, registration year, mark, like this. Okay. Anomalies. Anomalies mean uh, uh, how to implement database. Uh, uh, no, actually anomalies mean incorrect insertion of data. For example, lecturer ID name, address, salary, department, building, phone number. Inserting anomaly, inserting a new lecturer to the lecturer table. Department information is repeated. Uh, um, if the table has these attributes, in a single department name, there may be several lecturers. So if we insert department name, we have to uh, enter each department, enter department name in when we enter uh, each lecturer details. Deletion anomaly is uh, when we delete a lecturer details, the department details also will be lost. Updating anomalies also like that. Table, I will give example for normalization. Normalization is this uh, uh, removing these anomalies. One is insertion anomaly, deletion anomaly, updating anomalies. Because most of the time they are repeating. But it is very difficult to delete and some when we delete one row, we have to delete all the data when we updating also. Like now, I will explain by this example here. Now here you can see student program course. If we have a single table for all these things, we have to write registration number, um, program name, course code like this, registration year, marks, all those. Here you can see this course also took obtained by this person. Here you can see empty row here, empty row here. So this when we uh, create table in electronically, we have to access all these rows. So when we accessing, we have to repeat this name here, registration number, name, program code, program name, like that. So we have to include same registration number here also. 2122 should be included here also. So we can separate into the two tables because of this problem. What is the problem? Yeah, we have to write here also 1111 here also in this row. Here also we have to write in 111. When we even we can understand this table here. We cannot implement it in the electronic table, electronic database. We cannot implement it. So we have to access this as a row, this record, all the row. So we have to separate this. We have to separate. This is the first normal. Remove repetition, separate into two tables. Here registration number, name and the program code uh, we can separate into two tables. So now here um, registration number is here and the course code is here. So we can access this table by using these two two values. So we can separately um, create student table here. So if we change the name here, uh, it will appear only in this table we have to change. Therefore, no problem in each view. It will display in different data, but only this name appear. Okay. Now, second normal, if it is in first normal form and all of its attributes depend on the whole the primary key. Here course. The registration here is not in this one. Registration is not depend on this course code. Okay. Now registration number is not depend on this course code. So we can get the separately marks, and here the course code is we have to separately take out the course code, course name here, and the course student name, and also there, and the marks registration number. This is a combination concatenated. This is called concatenated key. Uh, Registration number, course code, and the registration year is the primary key here, mark. Okay, now BTech name is also not depend on this one. If it is all the attributes depend on all the primary. Third normal, every non-key attribute in the second normal will depend on the entire depends on the entire primary key. Now here the BTech is Bachelor of BTech BSc not depend on this one. This depend not this depends only the BTech. Therefore that also we can take out. So program code, course code, the course student, there are four tables here. That is a normalization. Okay, thank you. I will give some examples here. Okay. Now this is PHP MyAdmin. Before PHP MyAdmin, you have to do it this in the lab. We have to install this SAM server before running this. So I created here database is student info here. Table name, one table name is student, other name marks, no, course. Course, C code. Here you can see int. Here you can input data types. C code, say length is 4. Primary key. Okay, now here you can see this pop-up window came. If it is primary key. mm, Other than this table, there is a separate another table is created. One single table related to the primary key. Using this, only the primary key values are there. Only this table search, when the database and table search, only the index is, this is called index. Okay. Yes, here index choice, index name. Index, when we when the application search the records in the table, it will only search within this index name. After searching this index, uh, if the relevant registration number or something is available, then go to that table. That is the easiest way. Vacha 10. Because there are two. Course code, yes, that's okay. Now, you can see there are two tables, okay? Now, okay, I will stop here. And if you have any problem, please ask, okay?
සයි මේක අපිට මේ ඉන්ස්ටෝල් කරගන්න කොහොමද සර් කරන්න ඕනේ?